So the given in this question is that R134A that undergoes a isothermal process in a closed system at pressure 320 kilopascal, which we take as a P1, and at temperature of 40 degrees centigrade, which we take this temperature T1 and also this equals to T2. While there is also given X2 that is 45%, which is 0.45. While our diagram of this is the figure of TS that is quite like this 2 and 1. So now here's the solution start for this. We take the energy balance for this system that can be expressed as energy in minus energy out that is equal to T change of rate of energy of the system. So that our work in minus work out that is equals to del U that is equals to m u2 minus u1. So now the initial state properties are as we have to find these values. So the initial properties where's the P1 that is given 320 kilopascal and T1 which is 40 degrees centigrade. So from these we comes to know that U1 is equals to 261.62 kilojoule per kg and S1 which is equal to 1.0452 kilojoule per kg into Kelvin. So these are from table A13. So now for this isothermal process, the final state properties are from the table A11. So our as we know that our T2 is equals to T1 which is equals to 40 degrees centigrade and X2 that is also given which is 0.45. So from these we come to know that U2 is equals to UF plus X2 UFG. So now putting their values that is 107.39 plus 0.45 into 143.61 so it equals to 172.02 kilojoule per kg. While the S2 which is equals to SF plus X2 SFG. So this equals to 0.39493 plus 0.45 that is X2 and SFG that is 0.52059. So this equals to 0.62920 kilojoule per kg Kelvin into Kelvin. So we write like this per kg into Kelvin. So now the heat transfer is determined from Q in, that is equals to T naught S2 minus S1. Now putting their values, 313 Kelvin, that is T naught, and S2, that is 0.62920 minus S1, that is 1.0452 kilojoule per kg into Kelvin. So it equals to minus 130.2 kilojoule per kg. So now the negative sign, as the negative sign shows that heat is actually transferred from the system. So that is Q out, which is equals to 130.2 kilojoule per kg. So now the work required is determined from the energy balanced equation, which we have discussed our energy balanced equation. So from energy balanced, work in, that is Q out plus U2 minus U1. This comes from our energy balanced equation from this one. So now putting the values, which is Q out is 130.2 kilojoule per kg plus U2, that is 172.02 minus 261.62, that is our U1. Their units kilojoule per kg. So by solving this, our work we have to determine is 40.6 kilojoule per kg. So this is our required answer. Thank